Nē, kamerā.
Ko kamerā?
Atkal pusē.
Skatos uz kaut kas samīcīs ar roku. Kas?
Mēs ņēmām no sāna, pirmiem slāņiem, piemēram, viņš uzreiz atsaka no sāna vienkārši. Tāds variants arī. Daļai cik slāņiem vai
Welcome everybody to this nice, sunny, very hot Latvian summer day. I'm pleasantly see so much technical people, makers here who choose to have this nice meetup instead of the beach, summer beach and other leisure activities. So we didn't expect so much 3D printer enthusiasts here in Riga. Actually, this ecosystem is pretty big, as I see. Technical meetup group in a so small country and so small city as Riga, with 50 members in just 1 month is kind of surprise for me. So yeah, I will be host and for this meet. My name is Riga. For those who don't know me, you could follow me at Twitter or handle Riga. So this is my email, or just write me some email in meetup.com in order to have questions or ideas about future meetups. So I'll introduce you shortly about today's agenda. So I'll probably will skip personal introductions because usually we make for smaller crowd of people. If we introduce yourself for just 1 minute, we will lose some kind of half an hour. So probably you will meet each other after meetup and introduce yourself to the other guys. So I will shortly tell you about history and background of this meetup group, why we're here, why we're doing that. Then we have 4 speakers today. I suggest that every speaker will have some kind of 15 or 20 minutes. And the Q&As in order to be done in some hour or so, and then we have an open session. So everybody who came to the meetup is free to speak out what you're looking for, what you need, what you need, and or other stuff. And then we have brainstorm session about next meetups and speakers and other stuff. So this is part which I would like to skip here. So very short history how I decided. I'm actually organizer of this technical meetups here in Latvia, and this is one of the tech meetups, last one probably, which I decided to make. The guys from FabLab asked me to do so, and together decided this is probably a good idea for Latvia to make some kind of 3D printing some meetups. By myself, I'm a technology entrepreneur. Past of some time of my entrepreneurship I spent in Silicon Valley. So probably this is a place where most active technology things are coming out. So, and I decided to bring out from Silicon Valley this meetup culture here to grow this different technology ecosystem parts for the meetup groups. And one how I found out about 3D printing is actually the organization called the Silicon Valley Forum, which is very active in the San Francisco Bay Area. And there's this interest group which is called 3D printing. So I have been on several meetups there in San Jose and in San Francisco, and I understood that this is a really exponential growth industry which is going out pop up very soon, and this is kind of very interesting for me personally, because if you it's very disrupting the industry, because you're actually changing the whole world distribution model, how things are being delivered. Instead of building them in China, in a couple of years I see that everybody will have some 3D printing machine at home, and then just buy some kind of drawings, and in the minutes, no delivery times and other stuff, will make some kind of good or object in their homes. So in every meetup we informed, probably is the right word, inform about related technology events going on in Riga. So this is a couple of other stuff probably you're interested in or don't know about those activities. So next week will be in August 5 will be Bitcoin and cryptocurrency meetup, where we're talking about Bitcoin and cryptocurrencies and how to implement them in Latvia. Probably we'll get some Air Baltic guy talking about how they implemented the last months. First time in the Baltics. The next meetup is UI UX Riga meetup, where there's quite a lot of designers, which is around 100. This group grows very rapidly in the last 3 months. So we're talking about user experience and user interfaces, how to build, and if you would like to meet some kind of designers or people, just come to the August 18 to the mill, which is in Riga Street, and meet the designers. For entrepreneurship, there will be a meetup in August 19, which is called Find Your Co-Founder. It means that this is an event especially for those who are looking, have some kind of idea, but looking for co-founder to develop this and be viable, some kind of startup. And there's one more parallel programming and gaming meetup, which will be held in September 9. We're talking about computer vision, computer learning, and other stuff. So probably those who are interested in those things, you find out the meetup. So in every meetup we would like to stress out some kind of feature startup, because we're very lucky that in our countries there's startups in different industries, technology industries. That we are not only consuming technology but creating technologies. And in 3D printing terms, we found out for today, Mass Portal, probably the guys told us a little bit later how to make 3D printing machine here in Latvia, and then how they did it. And a few words about sponsors. One is about FabLab. So FabLab guy probably just tell about a few words about what's FabLab, why, because we're here in the Latvian University incubator.
Should I speak in English, right?
Yeah, sure.
Okay, so I'm from FabLab. It's just a room over there in the second room, and right now we have our 3D printer, small MakerBot, and a laser cutter. And basically the idea is that any people can come and use the machines for some cost, and they can make their hobby thing, or they can create their prototype for the business idea, and or whatever they want. So if you like, you can see that's the address, and there is also a contacts. Also on that banner there is a contact, or come over me and we can talk about it. So if you want to use the 3D printer by your own, then you can do it over here in the University of Latvia. Yeah.
Okay, thank you for FabLab for hosting the event. And second sponsor is Riga University Foundation. It's actually a foundation to grow up in an accredited non-profit, private elite technology university. And this is why I represent this university too, because it's very interesting to feel background from the industry, what kind of education do we really need. And as you see, there is some kind of course we are going to develop in forthcoming year, in fall this year, in winter next year. The course name you can see here, like parallel programming, iOS application development, technology entrepreneurship, UI UX design, Bitcoin and cryptocurrency. And there's the idea for 3D printing and 3D CAD design. Probably there's some kind of space where there's a demand for guys who is specially trained for 3D printing, some kind of industry. And this is why I'm asking for you, is there ideas for curriculum or instructors, for English speaker instructors for those courses here in Riga, for 3D printing and 3D CAD design? Is there demand for such kind of courses? Do we need certificate for 3D printing and design? And probably do we need some demand for, is there demand for 3D printing bachelor or master degree? I don't know how it's called, what is trends in the world, but this industry is created very, very rapidly, and I assume that there's no accredited programs in 3D printing because of the very low adoption adoption time from conservative industry like high education. So we partnering with roots, strong roots in Silicon Valley. This is also major partnerships which we have until now. Udacity is online mode provider, educational course, and Media is providing the graphical card and infrastructure, something like that. We're planning for Silicon Valley Camp for summer 2015 for our students, like 1 month in Mansion, so probably this will be interesting for coming students. So this, here we are on a way where we could start about our speakers. So Edwin's is the first one. Yep. So and we could he will talk about his discovery about what's going on in 3D printing domain in Latvia and share experience. So please, Edwin.
Okay.
Floor is yours.
Yes. No. Oh. 5 years ago, I went on vacation to UK and stayed for 4 years. And there, in London, I just grow in maker community, and yeah, it was common to have some wrapper printers, and maker bought first models, and it was common for me to have some common idea, to have some non-standard small thing. You just go and print it. When I went back here, I just think, oh, okay, we are in tent of internet providers. We are okay. When you go outside Riga, you can see, for example, lawn-moving robots. Like there is this Spider Dvorak robot which just cut grass on the slopes. I decided, okay, I'm in a very good country. I'm back. I need some printing, and I started to Google Zoom. I started to use Yandex, Bing, and all search engines gave back some, between 8 and 10 results. I started wondering what's going on, where's the 3D printing community? And while I was in search, I found PubLab and started to use, first I became a PubLab member, and then I started to use MakerBot, and just at the beginning it was more for testing purpose, for just fun, some small things, some gears, and usually for my work, I'm working in radar-related area, and there's some weather stations involved, and usually it's in some area high up, some 45 meters, for example, or somewhere you have some hydrometeorological device in 8-meter depth, and you just occasionally need some non-standard thing, some plug or some bracket, which you don't have. And because of that and my previous maker experience in London. And for me it was just not a thing, just okay, let's print. No, nothing. And I started to search and look around, and what I found out is that here in Latvia we have 3D printers. We have companies who do things, but CO part is zero, nothing is done. Yes, there, I think here in the auditory we have Baltic 3D. In the last week, if you Google it, they will appear more and more in search results. I don't know what they are doing, but at least something is happening. And, yeah. That was one thing. After, if we look on printed press, till this moment, from August last year, we have just 3 things. It's 2 magazines, 2 Latvian magazines. It's last July Uzzini, and not July, I think it's August Uzzini, and this month Illustrētā zinātne. And in the Russian auditory there is this month Hacker magazine. All of them stores just in articles, just small surface of 3D printing. And the conclusion is there is no information about 3D printing in Latvia. There is no articles, no things which relate to 3D printing, and usually consumers do not understand that they need. Because I went back to Latvia, I started meet my friends and older common colleagues, and etc. And for example, I met some old architect guy, and somehow we started to discuss about 3D printing, and at the end he just questioned, answered, oh, nothing. It's related, it's like, oh, what the fuck, why would we need it? And I explained what it is and certain, but at the end he said, oh, no. I can cut quicker with my scalpel, and we'll have this architectural thing much quicker. Okay, I think my decision was, okay, it's just one case. So then, for example, in my work, I arranged a meeting with Mass Portal, because we need work area 3D printer, just to have some presentation. But somewhere in a bureaucracy lines there was some big stop for a couple of months, because there was the same thing, nothing. Because nobody will understand why some department had both 3D printing. You can explain the need, and there is already collected some 100% agreeable things that it's not for just fun. We will not print some chess pieces or some dildos, some bosses things that it's more related to some tool which will shit out some Lego bricks just on demand. But slowly we are going forward, and I think till September we will have this meeting with Mass Portal guys. What was more okay, paper. Just got that. Look at this. It's hard to be first in the quiz. Okay, I will cut my story. I decided just for quest to look around if it's possible to have some cheap side 3D printing. And by my search, I found out about printer about simple open source printer, which has wooden architecture and all things is cheap and are kept to cheap producing. And yes, I'm building two things together. One is about simple, and second is Ultimaker Original, which is high-end stuff from cheapest possible 3D printers. And yes, I did not choose to build a RepRap. For me, it was common to have all those things from UK experience, but I decided to just have Original because it has nice case, nice looking thing, and you have most of possible changes, updates, and all community. Actually, it's much bigger than RepRap community. It's very interesting when you start to Google and read forums. Then you will find out, yes, RepRap model-based architecture was first, but Ultimaker Original, Ultimaker 1, 3 is wider. And I started to look around for example, laser-cutted pieces. And my experience went wow. When I started to look around for some guys with CNC machines or laser cutting device, I found out that yes, we have a little bit better situation in Google search. And the second thing is guys don't read your emails, they just say price. Oh, it's okay, it will be around 280 or 325 euros. And on phone conversation, you get that they didn't open your DXF file, for example, and never checked what exactly you sent, they just call this price. And because one of my friends, I found out about one guy who created some musical instruments, and through him, I found out another guy who actually has very good laser cutting machine and do in a readable price. That was one thing. Second thing, I started to look around for possibility to have some Latvian based PCB plates and some producers who will do electronical side, but it went to dead end because one which I found out in December actually went bankrupt, and till that moment nobody will create for you some electronical part for 3D printer here in Latvia, and it's cheaper to order in eBay, or at least try to have some eBay parts which came from Europe. But it's nothing because everything is produced in China, and it's still, at least something goes to Europe there, and then it's checked up. And next thing, I started to think, oh, if I have some laser cutting guys, and at least I can have somebody who will produce me some hot-end printing head, but I'm still in my search quest, and yeah, nobody actually did this precise cutting and CNC thing. Yes, I already cut all my story as possible short, and here I am with everything what I found, and conclusion is we need at least some portal which introduced 3D printing in Latvian auditory and in Russian auditory, which brings together 3D printing community. If you look, you can find some forums, just one forum which is related to 3D printing, and especially it's a RepRap. Maybe somebody is here from this forum, and they are from the forum. I understand that there are guys who actually are building from the beginning, when the RepRap model was brought in masses from 2009. Actually, they are doing something. The forum keeps tracks only. It shows up that some message appears just in 2-month scale. At least they are not that, but something is going on. And yeah, that's it.
Okay, thank you. There's questions and answers for the speakers. So yeah, there are questions.
Question about, you talked about chains production, yes, mass production, cheaper prices, yes.
Yeah.
But what about middle orders? 100, 200 pieces, jewelry printing. You try to find this in Latvia. In Latvia, I know many companies.
Yes,
with
but when you start to search, you will find nothing. You actually need to know how a company is called, and you, for example, just try to Google. And as normal people, I start to look for 3D printing related names. For example, 3D printing. It will not give you the things. You can play around in Google, for example, with local pages, with local pronunciations. There will not be things.
Sorry, but 3D printing is only part of process of manufacturing.
Of course.
If you find hockey player, you don't write in the Google hit to the.
You can just ask, for example, produce some object or.
Yes, maybe.
And it will give you just.
Because we
one thing.
4 years working in Latvia with 3D printing, with small 3D printings, with
yes.
jewelry printing, and
I think you are in my list because I have 8-10 companies.
Yes.
So
which I found.
Could you name those companies actually from the list at least?
Yes, list very good.
Okay, here are my collections. Okay, here was
Could you read it out?
then was Creator, then was Smart Engineering, then was Baltic 3D, then was
No.
and sorry, I have next list. When we have some printing libraries, then there was Carrot.
Нет. No.
No. Okay. And maybe I didn't find because I didn't look for jewelry.
But I make advertisement in Europe, but you try to find only in Latvia.
Oh.
In Latvia, no market for these things. So many people give advertisement in Europe or in Russia.
Yes. And when you look around, you will not find pointed directly to Baltic countries. For example, there is this 3D hub. I think here should be Pavel from 3D hub. And when you look for geographical location, you will have everything outside, but not in Baltic. In Baltic you will have less than 10.
Okay.
It's not about, yes, there is physical companies, but you physically will never find if you will not know that company, if you will not know product, if you want to just 3D print something. For example, some small case for where to put some PCB or some plastic piece. And we'll start play around in search engines. You will not find what you're looking for. It's not about where, but you will not find here in Russian, in Latvian you will not find. And in English based you will find the closest. It's about Germany, it's about Poland. There are hundreds in Czech and Polish sites which provide printing and which actually work with Latvian related orders. It's strange, but and if just open the Chrome and put some IT related not disassembling things, but just look on code, that you will find out that most Latvian-based companies don't use SEO. Search engine optimization, zero. Nothing is related just to popularize the thing. Maybe Baltic 3D started it, but it's...
Next issue.
So, you said about this problem solving, can you say your proposal again?
Oh, one thing I started just to prepare some domain, but it's still in progress. And I started just to throw together some good English tutorial and industry-related printed press for Latvian consumer. Just explaining what 3D printing is, what you can gain from it, what you can actually do. And
so basically my work is 3D printer, but I build only the moving parts, so I can arrange that with my school, so it could be a robot arm. No. Yeah, it's part of my master. Yeah. So I built a Delta robot printer. This is the picture where you can see 3 towers, 3 arms, which connects to in the middle, where you can put your spilled element, extruder, but okay. And under all of that, there is a microcontroller and a motor.
Can you tell exactly what this thing does in this 3D printer?
How it is? How
Yes,
it
because
works?
for example, what is actuator or what is microcontroller? It's
It's gonna be a long. I want to keep it as short as possible because I haven't been
If someone has
prepared.
a question, then you can go and talk to Christos.
Yes, there is a wooden tower, so it's made by me, and you can ask questions if you want. So later.
You can ask questions if you want.
Okay, I will do that. For my old teachers, it was a very good presentation, but I think for you it's not so interesting because there is all parts of.
You designed it by your own or
No,
just
it's
download from video?
downloaded.
Ah.
Everything is for free. If you look, you can find. So, and there is how this works, how all that works. I think it's too complex for me right now to talk about it in English. But I think if you want, we can talk in that room. Microcontroller. Arduino Mega, the biggest, strongest microcontroller from Arduino. So then there is a RAM, which is basically designed for retro, and only the software is changed to work with the 3 towers. So there is a little difference between RepRap and Delta Robot. So, there is all the parts. I don't know. Any questions about those? Everything?
What is it?
What is it? I think that. No, I don't know. We can talk about there.
Where did you make those parts?
In Fab, yeah. And before that, I didn't know that in Latvia there is a 3D printer, master. I didn't know about that, and then Krish told me, and it was a big surprise, because they use the same mechanical construction as I was trying to do. So,
You said a word laptop. What does it mean?
laptop?
Yes.
It's a printer, there is one. I don't know what those acronyms mean, but
Repro means a machine that is capable of replicating itself. And that's the goal of the Repro project, like building machines that can reproduce themselves. And theoretically. And practically it means right now that we can like print out plastic parts on the printer and like assemble a new printer. And then of course it needs some engines like stepper motors or something. Theoretically that's the meaning of word Repro.
yes.
Are there any benefits using your Riga?
I choose that because in that MakerBot uses backup coordinates. How it will be? Cartesian coordinate robot, but this one is a delta robot, and Cartesian uses one motor to move one axis. But this robot, to move one axis, you have to move all three motors. So it's stronger.
Printing more reliable, smooth, or is it just
I haven't been checking how it's printing because I don't have so much time, and for robotic arm, I have enough time, but nothing more. So about printing, I can say nothing right now.
So last question?
So is it so that you build a 3D printer and right now it's just at your home on a desk? So how are you using it right now after your master thesis?
It's standing in the corner because, as I said, I don't have any time right now because I started to work and there is no time.
Do you want to sell it maybe or?
No, I will continue my work on that because there is a lot of things to do. And in the winter, when there is nothing to do outside, I think it will be great.
And do you think, was it easy or hard to build it? Was it easy to find information?
Information...
Like for a guy like you who studies electronics? Find it is easy, I think, but it's harder is to understand how it works because there is no such a thing, such tutorials where you can put those things together and so on. You have to figure it out by yourself. You just see, you desire it, and you think everything possible to make it. So there's that beauty.
why you choose the Delta model?
It looks really cool. The first thing, it was very attractive to my eyes. The movement is
I agree, it's wonderful.
Yeah, it looks just crazy. And those things. No, man će se par tā masī.
Small question.
Use for this printer. What software?
Software, there is the same thing for RepRap, Marlin, but it's a little bit overdue to fit Delta robot. There is I think, I don't know, there is some lines where there is a mathematical equations which allows from X, Y, Z to ABC towers.
Small question. Is it very expensive to make a big printer to make furniture? Because now 3D printer is useful. What you can make on too small.
Yeah,
Too small. Jewelry or nothing. But then you can produce a printer what can make furniture.
Yeah.
Will be really revolution, because all people make choice. They come to shop and
Yes.
very long time have to choose something.
Yeah.
But if you can draw it, see it on 3D model on the desk, push the button and make all furniture in your house, it will be a real revolution. Is it, question, this is expensive?
For big printers,
For big printer.
it is expensive because I think
Why? Why you can make your connectors longer?
I can shorten them as a
There is
moment.
one example right now. CMC company is building 3 meter high and working area is 1.5 meter wide.
Delta?
Yeah, Delta.
I have seen.
They just want to rebuild their own CMC standard Delta, well, just 3 meter high working area.
No need 3 meters. Maybe 1 meter. 1 meter.
I think it would be very expensive
I need
to be a person.
Now I can find half a year 6 good chairs. I can draw it and print it, but I need printer 1 meter high. Is it possible?
It is, but
It is
people have
possible.
a very big headache just to calibrate it, just to have a proper head.
It will be slow, very slow.
Normal. One chair in the shop prices 10, 200, 100, 200 euro.
No, but
So, do you know some guy who have money?
it would be expensive.
But this printer almost good.
It is
60
good.
centimeters, 60, but I need meter.
No, meter is only the device, but the working space is not so big.
I want to say that if you want to make furniture, it's generally better to make it from plywood and from laser cutter or CNC mill. And there is homepage OpenDesk which shares designs for laser cut furniture.
Laser cut is not what I need.
From parts.
I want chair with biological design.
Oh,
A fractal something.
cool.
I have designed it. I have it on my computer, but I need. I can cut it to 3D print, but 60 centimeters too small.
There is one guy who is making big printers.
I don't know.
I will later introduce you.
Yes. Okay.
Okay, we need to go forward to the next speaker. Thank you, Chris. Jans from Mass Portal is next about great Latvian startup.
Okay, hi. I'm about to tell one story, and my colleague will tell another story. The two stories are a bit intertwined, and it's basically about if you are making stuff for your own, you are like called maker or hacker or thinker. But if you want to go further, make some product out of it, business or something, then you are more likely to be called prototyper and do stuff that's called prototyping. And I'm going to tell about how we've been using in our company, Mass Portal, prototyping to come out with our product. And the thing is that 3D printing is the enabling technology for us that has allowed us to come out with the product in such time that we have been allowed to and in such budget. And without 3D printing, it wouldn't be possible. And it all started out like this by Mr. Alvis Narmonds, who is over here also. And this was, as all great companies started in garage or in this case in kitchen. And so after a year or so of thinking, it got thrown out of the kitchen and needed some new place and some new dreams, and so this was the digital dream of the next product that's will be for sale, or will be the company built around it. And so in case of prototyping, it always starts with some idea, whether it's sketch or 3D file, or and so here is the product already next to an Ultimaker. That was about to our office to fix it. So then, once you have the first printer, we sold some of them, and we had a cheap Delta printer. It was priced substantially below what other Delta printers on the market were going for, and we sold some of them and had like references from customers along the lines that it could even not work for the money, we would still buy it. So, but it turned out we want to have a higher quality product for business reasons. And then we started dreaming about the next version of our product and prototyping that. And here we go. For example, printhead. We are not building Chinese components that putting together. We want to build a beautiful machine and an original printer, so it's a lot of it is built in Latvia, made in Latvia. Over here, some companies who help us with metalworking and electronics, and now also with software. So in this case, 3D printing helps us to prototype the metal parts in the first place, and they are printed on our printers. This is ABS plastics, and it allows the parts to be tested. We can go through lots of iterations. We make some models, change it, print it out, and some components of the printers have been like through 20 iterations, maybe more, till we find one that suits us, and we can test them out. And the parts are sturdy enough. They can be used also for limited volume production. And that's essentially the key to getting the product to work as it should, because if you have it only like in the 3D, you never know how the material or how it works out in the real life. So the essence of prototyping is that you can test it out and show some other stakeholders and basically touch it a new version in very short time and very, very cheaply. Basically at the cost of the plastic filament, if you have the printer and the ability to model it in some 3D software. So that's the final product for the previous edition. Now it's again undergoing prototyping, and so it just iterates forward. Here is the result of the previous prototyping work in an exhibition, and again prototyping a different component of the printer. That's the linear guide system that you also saw in the previous presentation called Delta, but we started out also with metal rods, with calibrated rods from a very good supplier. And found out experimentally that not only that, but all the components have to be of very, very high tolerances mechanically. So we are now moved on to linear guide system that gives better precision, but these parts are how we get there. There's lots of experimentation, lots of back and forth, lots of consultations with different experts. And not all of the prototyping happens on 3D printing, and as you see in the bottom pictures, we have done some prototyping on aluminum as well. So that's just not the way to do it. It's very expensive to have these CNC parts cut, but sometimes you just don't have the time to print something, or your filament has run out, so we did a bit of that as well. And also, again, here you see some part that's printed out, used in real life situation, the tensioner of the belt, just to check it out how it works before it's sent to CNC machining, and that's the final beautiful part, and that goes into our production. So this is a real life story of
how it looks like, the prototyping process, you just one printer for a person is never enough. It's not that fast yet, so you can churn out far more models than you can print on one printer. So it's nice to have some of them, a number of them, and we are of course a bit privileged in that regard, but still. And the next story is actually, I will maybe ask Juris to tell it. And another product that's also gone through this prototyping and now is being shown to big investment stakeholders to evaluate it. And so, Juris.
Okay. So my name is Juris Glava, and I'm hairdresser, but I'm head of development in Mass Portal. And how it starts with some hairdresser who are technically thinking and discovering that in the world women don't have some good device what not damage hair and very handy and hassle free and blah blah blah. And then we fly in cruises, and I had time to learn CAD, to search what we have not in Baltics, and we have not till this moment infrastructure for making things and infrastructure to thinking about making things. That is very bad that we're talking about innovations, about how to land swim, but we have no pool, we have no idea how to go to ocean. And here is some, I start to draw it, then start to find how I can make it a solid real body, to just proof of concept. Then I lost a lot of money, nerves, and time. I find some services in Austria, Holland, and after the second prototype, my money points asking, it's not enough for you. You don't know everything about that. Then I just write down the article about Dyson with 1,500 prototypes, and then he makes some molds or some product. And here is printed parts. This is in my home. I bought some MakerBot. I really bought what is the most common apparatus in the world. I have no money to pay 2,000 euros to Austria, 2,000 euros to and I bought a MakerBot in my home, and then it starts, and then I understood that no one will stop me if I get some machine who can make everything what I need, what I want. Of course, I don't make jewelry or bumpers for machine, but for my new high dryer, it's quite suitable. and I can stick it together if it's necessary. And here is further. I don't know how much prototypes I made, but if you go ask for money givers is big childs. They want to touch to see how it looks in the stock and how it works and what my wife thinks about that in that colored lamp or something like that. And what I want to say, there is no problem to get our ideas in real products. Go to Kickstarters, Indiegogo, go to Business Angels, not in Latvia, in somewhere else where is the money, and just cry about that we need it. It's very, very important that we have for this swimming, we have a pool, and then we go to the ocean, because we have, I think, in Latvia many people who has very great ideas, only with the communication and just to maybe some Google. Huh?
We need forum.
That's okay. I was a little hydrogen, then after some things.
Okay.
I cannot wait for the forum. I need infrastructure, and if it's not we made by ourselves.
Yeah, we even prototyped our own logo.
I hate blah blah blah. I want to make something.
Let me. Thanks, Yuri.
Any questions?
Let me come just very short back to this picture. And this is also 3D printed. And the thing about 3D printing that everybody tends to overlook or doesn't want to hear is that the parts are just parts, plastic parts that need some post-processing. And this is printed on the same chip printer, just later on post-processed. Painted, polished. So you can have prototypes of that quality on the desktop printers. You just need to invest some time in it and some willingness to go there. It's entirely one of a kind. It's working. It's stuffed with the electronics, but it's made on the. It could be made like on a $300 reprop, probably, without the finishing, of course, but the parts. So this is really the enabling technology or the disruptive thing that you can get this kind of. You can investing some of your own cash or time or something. You can get to that level of prototyping that has not been available up until now. And that's the enablings that these cheap 3D printers give the people. So,
Any questions from us?
Can you say something more about finishing techniques you use?
You can later on go into specifics with Yuri, but this is, I think, polished, sanded and painted, and after that polished again and so.
Maybe there is some very low technology when you use acetone wrappers.
Exactly. This is ABS plastics. The same industrial plastics is it's molded off afterwards, so it's also behaving in the same way. And of course, it has these layer by layer qualities of being printed by an FFF printer, but it's comparable in some ways to the strength of the molded part. You just have to take it into account that it will be more brittle in some directions and so. But generally, the parts are usable for prototypes. They can be used.
Who was this vaporizing meters? In vaporizer or some device where you vaporize, you cannot very good control. Yes, wow, it's too much. Yes, vaporize it, and it because hard to control. If you make it polished by some nile, sandpaper or some Dremel, or then after then you can paint it like a car with there is a lot of sometimes molded parts also is painted, how you see, because the depth of the surface is very depends from this. It's better to paint for the name message if you want to the ink or something to that better paint.
Question: can you use for polishing any sparklet?
Sparklet?
No, sparklet.
Yeah.
Yes.
It's possible.
And it fits. Not.
Yes. That's the spatzel for car.
Yes. Spatzel for car.
Yes, it very good sticks to plastic and ABS is ABS, and but also we have another method, growing with some this filament in Dremel. Just grow it with the big object inside.
No.
Yes, and there is a method just to make it without this waiting process.
Probably solve question from UK.
And speaking about mass portal printer, why should I buy it instead of MakerBot? Why should I choose mass portal instead of something else?
We were not invited here to pitch our product, but you can go back in that office and check it out for yourself. And generally, our printer is at the time supported in Latvia with like local spare parts, local service manuals in local languages and stuff like that. We are here. Like you don't have to wait for spare parts being sent over from somewhere.
Guys who talk.
And regarding the Dell,
Same day.
so we are not. You are gonna have problems with any printer, including ours, the first day, because you need to learn the product a little bit. But if you don't call us the first day, you probably won't call us the day after, and then it's going on. But still, it's nice to have the support available.
Janis, compare our Delta with MakerBot system. What is the...
But generally, the Delta printers compared to the MakerBot style conventional printers, they are just less vibration and less noise. And you can just run them faster because they don't have this vibration. They are... That's...
quite faster than that system and quieter.
Also, our printer can print with materials like ABS, PET, PLA, nylon, which MakerBot, this for example, can't. So
that's into specifics, it's very open. Ours is like proprietary hardware, it's our own design, but it's open. You can like run it with different software and different settings and basically experiment with it. That's not possible with a lot of the brand name printers. They are like closed down.
Another question. I heard about machine who recycle bottles, plastic bottles, and print from them after. Is it possible with your printer?
Recycle models?
Is it possible?
No. There are devices like Filabot and stuff like that make filament at home from whatever you push into it. And then you extrude your own filament. It costs about $1,000 to €1,000. These machines starting becoming popular, and then you can make your own filament, and then you can feed it into the printer.
So is this filament?
No, we don't have that machine yet.
We bought some rolls.
But if I
yes, we can print with PET material.
Okay.
PET we can print, yeah. It's actually printing with PET.
Okay.
We haven't printed a lot of PET yet because it's like kind of new, but
you use your own or
no, we don't.
Any filament I can buy in China.
Yes. But you have to find your own settings that work good for you. Because the filaments, the settings for the filament that you need to have to get the quality printout sometimes vary even for if you have like two rolls from a single manufacturer of the same filament, one is white and one is black, and there will be different settings. So they are pretty fine. You need some fine tuning for it, just to have a time find out how it works.
Very good. Is there some interest from Europe or Latvia from schools or like a secondary school or primary school? If there is, then can you tell some examples? What do they do with the 3D printers in the classroom?
Print out girls, of course.
And maybe if you have some customers,
they are not allowed to print out guns, but there is curriculum that they're teaching, like SketchUp, for example, or 3D modeling in general, starting from like 6th grade or something. Very young guys, and they are very, of course, delighted if they can print out their creations. They have like been modeling, and in the higher education or so, it's altogether necessary. So.
Okay, probably last question.
Is there a way to print on 3D surface?
That's an advanced question. Short answer, there is, but it's not straightforward and it's not like out of the box.
Okay, thank you, Yannis. And the last but not least is Yannis from Multi 3D.
Hi everyone, I'm really glad to see that you have not cooked yourselves yet. As I was introduced already, my name is Janis and I'm from Baltic 3D. I'm here with my colleague Vidzis, and we will try to talk more about the other side of 3D printing, which has been very popular and very up to speed in Europe, in countries like Germany, for example. And at first I will touch a little history, but I promise you I will try to fit in those 15 minutes. So we initially started around 2012, the summer of 2012, when we decided that we want to buy a 3D printer and we want to do something with 3D printing. Over almost a year we were traveling around Europe and looking at different types of technologies, different types of printers, and we were trying to decide which is the one that we need to buy, and we finally bought one in last year's autumn. Since then we've been doing a lot of prototyping, and we've evolved to being the local reseller of one of the biggest 3D printer producers, Stratasys. But I will tell you now more about the industrial 3D printing and what are the technologies, what are the differences between them, what are the materials that they use, because there are some differences with the classic desktop printers, and what are the main applications of these industrial machines. This is a very simple matrix which we did when trying to analyze the 3D printing market. It's basically all the big players that produce industrial printers, all the different technologies and the materials. But what we have been working on is that we bought a PolyJet 3D printer. PolyJet works a bit different than extrusion. It works much like inkjet printer. It has a printing head that moves in X-Y axis, and it has a printing platform that lowers itself on the Z-axis. What it does, it prints with the liquid acrylic photopolymer. It's much like the acrylic material that women put on their nails and then harden with ultraviolet light. It's very accurate. It's not as accurate as VisionTech or some other small-scale jewelry printers, but we can achieve a layer thickness of 16 microns, and we can achieve it while still printing fast, which is a difference when you lower the layer thickness on a desktop printer. It's going to get much slower. This is the fastest technology for accurate and detailed 3D printing. It prints with 2 materials at the same time, and this is the big difference between desktops and industrial printers. We use support material that's different from the model material. What it means, it prints at the same time with 2 materials. The support material is washed away after the printout is done, and the model material stays there to make the part. Support material is needed for all the overhangings, all the negative angles, and all the holes or any cavities. And you can wash it out for the polyjet. You can wash it out with the water. For FDM type machines or FFF type machines like Mass Portal, in the industrial printing they use soluble supports that actually solidify away after you put them in special solution. So I'll quickly run through the technologies and then we'll touch on a couple of those applications. This is the same printer that we have in our office. The dimensions are there. We have 7 different materials. They are more or less the same in terms of material qualities. They have different shades and they have including transparent. The polyjet, next level polyjet, and as you can see, it prints typically 16 to 32 microns. Then there's the next level machine that just was announced this year by Stratasys. It can print with at least 3 different materials, including transparent, including color, including flexible materials, and you can mix them in different proportions in the same part. That makes sure that you can print out the prototype, for example, of a calculator, and you can have the buttons to press down already out of the printer. You just wash it off and put in the electronics and it works right away. It also prints in very thin layers, and it works in SMIC color scheme using 3 colors: yellow, magenta, and cyan. At this point, this is the only printer that mixes material colors, not colors the material or printout from outside. There are several solutions that do provide colorful printouts, but this is the only one which actually uses colored material, not colors the part. I'm not sure if this is going to work. I had some videos. Fused deposition modeling or fused filament factoring, or I forgot how it was. Maybe you can correct me. But so FDM works industrial FDM machines. They're extrusion type of machines, much like these. There are several differences though. These machines work with industrial materials, and I'll talk about that later. These materials are, including ABS, are very much like the materials you can use in desktop printers. But then we have high performance materials like Alten, EPSF, and nylon that don't usually work on simple machines. They heat up the environment where you print, and that makes a big difference when you want consistency in your printouts, when you really need the first and the 100th part to look the same, and they heat up the environment almost to the degree of where the material is fusing, and then when you fuse it, then it cools down to a temperature where it's solid again, thus making a more stable and more reliable printing. The layer thicknesses vary. FDM can go below 120 microns, but usually it's printed in this layer thickness just to make it faster to get the product out of the machine faster. There's also selective laser sintering that sinters. You just melt the layer, you lower the platform, put another layer of powder on it, again melt it, and repeat the process. The unmelted powder serves as the support material, and the melted powder makes up the part. The layer thicknesses vary, but it usually runs in the 120 micron scale in a layer. And last but not least, and I heard there were several questions about size, one of the biggest machines that are made in the world, even 1 times 3 meters, are SLA machines that can create up huge and enormous parts, and they work with acrylic plastics, much like polyjet. You solidify them with the laser, and the material reacts to light, and thus you build up the part within the liquid. There are only a couple of machines that are that huge, but mostly you have smaller machines, including machines like VisionTech that work with SLA technology. Just a quick comparison, if you take 116 microns, if you compare it, you can see how much detail you can get out of a machine that works in a smaller micron scales. So we are at that end. We currently are printing, that's why we didn't bring our printer, because we're printing a large order and we can bring printer. But I'm inviting you all to come over and see the printer in our office in Riga. Yes, so as you can see, the FDM and the polyjet sides make a big difference there. And now with the materials. So we have, you could divide all the materials in 3 groups. We have ABS around here, which is the standard plastics. PLA is below the ABS plastic, definitely. And then we have engineering plastics like polycarbonate. And then we have high performance like Ultim, like Peak. Those are plastics that they're usually sent into the space. They're very, very solid. They tend to be even more solid than aluminium. So they can be used in very special cases, and Stratasys machines can print them. A bit different comparison lets you see where our materials are. So we're mostly below ABS or at the same level. Materials that we use in our printer are not meant to be as strong or as durable as ABS, but they are more accurate. So if you need very specific and very precise models, that's how you can make it. You can make moving models right out of the printer. You can have moving hinges. You can have fix and fit capabilities. And applications are endless. You can basically use those printers anywhere you can imagine. Our cases where we have been working, as most probably you all know about or have heard about AirDog, we help them to print a lot of prototypes. We printed in polyjet where we did their wrist watches, the air leashes where they had rigid and elastic materials in the same component. We printed them in ABS, in polycarbonate, and in Ultim as well. They tried to test out the more hard plastics and how they would behave in the air and on the model. At one point we had 5 printers printing for them. We have 1 printer in Riga, but we have partners that print in Lithuania and Poland, and we had 5 printers simultaneously printing for almost 2 days to finish their order. So this is one of the specifics that we provide as a 3D printing service provider. We can get you there. If you have a very special case, we will find you a solution to that, and we will do it, and we will bring it to you, and it will be done. So we really like to think of ourselves as one-stop shop. If you have a design need, or if you have a printing need, or if you want to buy a serious or large-scale 3D printer, then we can provide you one. We've been working with Massporto since last year when we met on the RigaCom exhibition. We had stands next to each other, and it worked out very well. Since then, we found out that we very much appreciate the community and whatever happens within the desktop printers sphere, because that all helps to separate industrial printers and what we do from the hobbies use of printers at home or small offices, and we support that because that's how you start. You need to have a family car first, and then you only buy a truck if you start doing heavy duty, right? So I'll just show you a couple of quick pictures here that I have. Logitech uses this technology for a long time. Both of those parts are printed, much like Jan said. You can post-process them very well. You can paint them, you can powder paint them, and you can print on them. So you get a model that looks almost like the real one. Some other electronics use cases. The new printer, this is not colored, this is printed right out with a colored printer. So you get parts like this that are out of the printer, they're not post-processed. Medicine, obviously, even some crazier cases with printing biocells and printing implants for jaws and then knees and whatever else. Prosthetics, printed on high-end SLS printers. And then we have metal printers that actually print metal parts from titanium, stainless steel. And NASA tried out printing one of their shuttle engines. It actually worked. There's Arkham-made knee and hip implants. That Arkham is a company from Sweden that does one of the best jobs in metal printing. And as I told you already, then we are the official reseller of the Stratasys printer line. There are more than 20 printers on the PolyJet side and on the FDM side together. We are a service provider. We print for anybody who needs a 3D printing service. We've been printing injection molds, we've been printing very accurate parts, and we print casings and stuff like that. And we are a one-stop shop as well. If you need something, we will find a solution. We will send you maybe to Fab Lab, or we will send you to these guys to buy a printer if your need is very specific and small scale. If you will need something bigger, we will try and help you with that and print it for you. I could actually show you a couple of printouts that we have done in the last few weeks. This is a ball prototype. It's not clean, so when you print on one side, you will get the support material. When you clean it, it looks like this. It was for one client. Then there's another ball prototype. This is done in FDM because there was not that much detail in it. This is very small figures, but I guess these guys can tell you more about that. This is not the best quality stuff. That's true. These are some ornaments for production. These are actually handles for furniture. One designer in Latvia did them. They're quite large. They're almost this large. So smaller printers cannot make them. And these are made in polycarbonate, so more durable.
What's the price?
The price varies very much, obviously. I can get back to a slide where we discuss the price and then I will get back to the slide and I'll tell you. I will name numbers as well if you want to. So this is aerial prototypes made in the Alten plastics. These are some PolyJet prototypes made in acrylic plastic. These are the combo parts which are made with the transparent rigid plastic and with elastic black plastic, and all together they make these remotes. You just put in the electronics and the buttons work right away. And they are printed at one time, so you don't have any assembly. Some more interesting cases, like here, Raspberry Pi cases, injection molds for silicon injection molding. And here we can actually achieve very, very high accuracy, which actually means that you can inject in these molds right away. This is a very specific case for small figures, but and there's silicon being injected in them. Some casing examples, and again some small things. And I'll go back to here. Yeah. So how does the price come together? First, it's technology. So there's FDM, there's SLS, and there's PolyJet. In PolyJet, we price every gram that we use plus the time of printing. In FDM, we price every cubic centimeter of material plus the time of printing. And in SLS, we price every layer. So for example, if you would make one of this or 100 of this, if it fits in the platform, it's almost the same price. because you price for the layer when you build up. So typically the prices for FDM are from 3 to 4 euros per cubic centimeter, and if you translate the PoleJet prices, they also tend to be in that range from 3, even sometimes to 6 euros per cubic centimeter, because there can be specific geometries that ask for a lot of support material or for very high detail and very high height of the part. That means that it's going to take much longer, and if we especially print in a clear plastic with a thin layer thickness, that would make up quite a big sum for just the prototype or printer. Yeah, I guess if you have some questions, I'm open to answer them. But apart from that, I have a bag of samples. You can come up to me. I'll give you my contact details. I can show you some samples, how it looks like, how it feels like in your hand. And you can always come and visit us in our office.
How much was this furniture elements?
It was 350 euros, around that. Yep, it wasn't cheap.
Oh.
Yeah, all 4 of them was 350 euros, roughly.
Also, was printed in one?
Huh?
In one print, or
Which
all 4 elements?
They were done in one print,
Oh,
yeah.
okay.
Because it's a bigger printer. The printer size is, you can go back to that. The printer size is this.
Okay.
So you can make all of them in one print, and it's very handy. This printer stands in Poland, so we use it a lot when we have bigger parts to print. You can even make a chair, because you have to print every leg separately.
What is the price for this printer?
A good question. We can talk about it later.
Your local.
No, I wouldn't even tell you, because what is important, what you need it for, and then most probably I can provide you with a solution that's much cheaper, or maybe if your need is not that big or fancy, then you could probably get through with a hobbyist printer or a desktop printer, and then you just go to Massport and buy one of those. And they're being very modest. I think theirs is one of the best desktop printers around here, and it beats MakerBot, it beats anything that I've seen so far.
Yeah. We're still working.
Yeah.
Any more questions?
There's another question. You touched on that. So you will obviously have problems with any 3D printer that you use. But the thing is that very many of the Stratasys printers are made for dummies, and I mean it in the sense that even your grandma might be able to print on them. It's made so that it's as easy as opening the file. The software does automatically everything you need. It positions the part for the smallest material used, for the most efficient printing, and you only have to press print. It depends from machine to machine how easy it is to maintain it. But for example, our machine is very easy to maintain. You can start printing the next part within 5 minutes after the last printout has been finished. You just have to take it off, you clean the surface, and you start printing again. Obviously, this software is licensed, so you have the ability to go into the advanced settings and screw up something. But as long as you don't want to go into details, you can't print very easily, and that's also a bit different from desktop printers. The software is not open source, and it's very locked.
Any more questions? Okay, thank you, Janis. So, Janis was the last speaker for today, and just a few other topics we have now is wrap up and announcements. So yeah, so you're free to come up here on stage and say what do you want to print, or looking for 3D designer job offer, or 3D printing service offer, so event announcements, startup projects, introductions. So any announcements now? Don't be shy.
Давай, скажи, а я еще
If somebody is about to start a 3D printing service on desktop printers, we will make a good deal for it because we want to support it. We don't do it our own. We are crazy busy building our printers and we are printing out girls, and but not just for the fun of it. But we are not doing real print service. We sometimes forward some guys to Z and to some other companies in Estonia, for example. But really, if somebody is like looking to start a printing business, we are very much serious in supporting it. Anyway, we can.
Maybe someone has some good contacts in the Latvian university bureaucracy system. Just to let these guys to make a good workshop. If it will not happen, we must do by ourselves, but we have...
You mean we need the open Fab Lab as open for consumers?
Yes,
or
but
something?
Fab Lab can be also commercially. Just to come and Fab Lab makes for you something. Yes, it's this
manufacturer
side of this Fab Lab. It's always that's normally that Fab Lab has money for this growing and the social entrepreneurship.
Yep. Yeah, got it.
There's a design center about to be like made in the Riga Technical University, but there's also bureaucratic challenges. So, but it is moving forward. So we should have our design like basically a Fab Lab, but slightly different.
Maybe we can create some power for to force this bureaucracy. Yes, bureaucracy.
Well, there's finally yes.
There's old guys that not understand.
Yeah, yes, there are problems, but we basically again there's the new faculty in Kyiv, there's the new building, and in the new building there are like few hundred square meters basically of place just for.
That's close to us.
Yes, that was very clear. Close. So.
Who will be the first?
Well, the first for workshop, or where the kids can go and where the interested people will just want to see what it is. There's no such thing here. Okay, Fab Lab, then you first need to join. And second, there's no workshop like Cafe.
Fab Lab is open.
And there will be a workshop.
There is officially new days. Anyone can come and you must deal with this.
So any other announcements?
Announcements for the forum. So if anyone wants to contribute. If anyone wants to help to make forum for 3D printing, then come to us and read and talk to us.
It's just the beginning.
Well,
maybe
we need
we
to
can
start somewhere.
on the start. Maybe we can make Facebook group.
All right.
Maybe
Doesn't matter.
3D printing Latvia. Someone make it and we just join today.
We can
Who make it?
There are several groups on LinkedIn also where actually we have been in that business for half a year.
Latvian groups?
No. It doesn't matter. This is international business as well as you mentioned.
I need our Latvian.
No, but the thing is that designer, it doesn't matter from where designer works, and the printer, this is the closest way. So for example, we have the only one polyjet printer here in Baltics. So our market is not only Latvia, our market is also Estonia, Lithuania. In order to market that, we don't need a forum in Latvia, for example, but we need actually LinkedIn groups where we can actually pick up also the designers we can work. In case there are some international clients coming and requesting us, we are not 3D designers, we do not design. But some clients may ask us, can you suggest some designers? What we need English-speaking designers. And there are several items, and I think a lot of LinkedIn groups can work with that.
Okay. You told me not to be designer, but I am 3D designer, yes? And
Okay. Hello. We're representing company Article RTIG. Yeah. And we are a manufacturing company that have 3D printing, 3D modeling, 3D scanning, all things in-house. Maxim is our 3D artist, and we of course provide all these services on demand, so you can come to us, tell what you need to model, if you want to scan something or print something, we can do it. We have an Vision Tech machine in-house. It doesn't have very large build platform, 6 by 8 by 24 centimeters, but it's one of the finest surface finishes on the market till this day. And we do it for the last 4 years, so we have a lot of experience, and we can make almost everything. Also, we have a bunch of contacts in other companies, also not only local. So yeah, same as Baltic 3D, we can be one-stop shop. Yeah, but yeah, and these are pictures. These are all made by us, molded, printed, also manufactured in metal. Yeah. So if you have any questions, yeah, that's
so we have a 3D scan.
Yeah.
How big object you can scan?
8 meters.
8 meters high, yeah.
It doesn't matter actually how large it is, because it's handheld. So you just, as much as you can reach it and you can walk around it, you can scan it.
But there's no limit on the memory for
it's quite powerful.
Not very good.
No, it's good enough to scan a person with a.
You need a sculptor to add some small details. So maybe buttons. Buttons will be like round.
So if I have a glider, the wingspan 6 meters, and the length is 6 meters.
6 meters.
Yes, and what would be the precision for that end file?
I think 3-5 millimeters precision.
3-5
Yes. So
a waste of your experience and your patience just to go around and keep all spots.
Smart engineering is expensive, guys, and you compare with
cheap.
You are cheaper, yes?
What? Compared to what? Compared to whom?
Smart engineering is the only service providers for 3D scanning that is for cool guys.
We doesn't use industrial grade technologies, so they tend to be very expensive, the scanners themselves. But our equipment isn't that expensive, so it's mostly the work of the specialist that is doing these scans.
We are very interested with, for example, from the Baltics, people who go to smart engineering, and from mass portal, people can go to you. Maybe.
Yeah, because the quality would be sufficient.
For this, I don't need this precision. I need something like that. Yes. Then it's good.
So about smart engineering, I don't want to make them bad advertisement, but I show you. I work with them. We scan, and after that, on next week, I go and buy my own scanner, because this is for these figures that take 100 euro. Yes. And figure OBJ file was completely bad. I fixed it 3 days.
You after processed quite a lot of.
We do post-process the models, but because we need very high quality for our miniature. Yeah, so the scanners gives out quite good, complete, almost manifold model, but yeah, we do need to add some small details to remodel something to even if we print our figurines in 5 centimeters scale, we still need very
so
high.
You saw this file, yes? But this is our scan. No. Just a second. Oh, this is our scan. So you see any difference? One day for fixing. Yes, I add buttons, I add zippers, I add belts by myself. But it's not too complicated to work with large and bad object with holes, with non-manifold parts and many bad things. So this scan can be made in half an hour. Half an hour, it's 1 try, 2 try, 3 try until we have the best. Scan, you see, is 1 scan make 1 minute.
And is it done with this your scanner?
Yeah.
My scan, this is my friend, this is my wife's head, and and we make it. This is D'Artagnan from old movie. We make it for a Californian company. American movie from 20s, very old movie. So this is another scan. This is Zombie Killer for one German company. Beautiful girl.
Also your friend?
Yes, my friend. my friend Rita. So
you use all your
I use all my friends because I don't must pay them. They like it.
What companies are doing this? They have good 3D situation.
We sell it. This is
our company is manufacturing company of this.
Of these things,
yeah.
yes.
They are more like figurine
for museums or
yes, for museums, for private collectors.
Yeah.
Many.
Yeah, but we do provide all these services because we do have all the technology and all the expertise.
So, what about this technology? Chinese people can make it more cheaper, yes? But we can make 100 copies, sell it to all worlds and make another figure. So, business go. We don't need to make 10,000. We just need to make 100.
And use some silicone mold? Or?
Yes. Silicon metal casting, plastic casting, all this mass effect.
Okay, thank you. And you have your scanner with you, so if somebody would like to see the scanner in action, so please ask guys and scan yourself and probably make it.
Who want to be next figure?
So you could ask them later.
Thank you.
I need zombie for my next project.
Behind you.
Who wants to be zombie?
No, I don't want to be. Okay, next announcement. Any more announcements? So anybody? Okay, so be prepared for the next meetup, which will be scheduled at the end of August. So probably you will then be prepared to make some kind of announcements and other stuff. So this is the very last topic. So there's a couple of ideas which we have from our presenters about how to develop the Latvian 3D printing ecosystem. Probably one of the ideas which I have here is about building some kind of consumer accessible coffee shop with 3D printing options. So probably it's a very good idea for a very growing market. Next idea is very good for this portal, or I don't know, a meetup group or Facebook page for the 3D printing ecosystem for Latvia, where you can find news and companies who is providing services. So probably we will be in touch until the next meetup and figure out how to do it. So we're looking for the next speakers for next meetup. So anybody, if you would like to share your ideas